So in this question we're asked to find angle x. Now the beauty of trigonometry in right angles triangles is the method is exactly the same whether you're finding an angle or a length. So the first thing we do, like we did before, is to label the diagram. Remember, opposite the right angle was the hypotenuse. This is the angle we're looking for, so that one there is the opposite, and this means this is the adjacent. Now you can see that actually we've got the information for the adjacent and we've got the information for the opposite. We don't have or we don't want anything for the hypotenuse, so I'll just cross that one out because we don't need that. So now, as we did before, we just write out SOH CAH TOA. We identify the two parts we've got. We've got O and A. So there we are, we're using the tan function. So in this case, we've got the tan of the angle, theta, is equal to the opposite over adjacent. Do you remember how it works? So what we have is the sine of theta, side over side, cos of theta, side over side, tan of theta, side over side. Right, going back to this function here, all we need to do now is substitute the values in. So we know that theta is x, so therefore we have tan of x is equal to the opposite, well the opposite is 6, over the adjacent, and the adjacent is 11. Now we want to find x, so we want x on its own here. We need to get rid of this function, the tan. Now you need to remember that the function tan is not on its own, it's actually with the angle x. So I can't just divide all of this by the function on its own, it needs to be with the angle. However, we are still doing the inverse, so the inverse of tan is tan to the power of minus 1. So therefore we write this as x equals tan to the power of minus 1 multiplied by 6 over 11. All we do now is put that in our calculator exactly as it is, remembering that that is a shift tan on your calculator. Okay, so I'll put this in my calculator and I find the value of x is equal to 28.6 degrees to 1 decimal place. Okay, let's look at another question. So the method is exactly the same. Step 1, label the diagram. Well, there is the hypotenuse. Look away from the angle, that is the opposite, and therefore that must be the adjacent. So we have the hypotenuse, we have the adjacent, and we don't need, and we're not looking for the opposite, so I'm going to cross that one out. So like the other questions, the next step is to write out SOH CAH TOA. Underline the parts we've got. Well, we've got the adjacent and we've got the hypotenuse, so therefore we're looking for the cos function. So write out the function, so therefore the cos of theta is equal to the adjacent over the hypotenuse. Next step is to substitute the values in, so we've now got the cos of x is equal to the adjacent, which is 19, over the hypotenuse, which is 28. And again, like before, we use the inverse of cos, so therefore x is equal to the cos minus 1 multiplied by 19 over 28. So our angle is 47.3 degrees to 1 decimal place. Let's do one more question. So exactly the same method. Step 1 is to label the diagram. So there is the hypotenuse. That one there is the opposite. That is the adjacent. We don't need, and we haven't got the adjacent, so I'll cross it out. Next step is to write out SOH CAH TOA. Then underline the parts that you've got. Well, I've got the opposite and I've got the hypotenuse. So in this case, we're using the sin function. So we write out the sin of theta is equal to the opposite over the hypotenuse. We substitute in the values. The sin of x is equal to the opposite, which is 8, over the hypotenuse, which is 12. Therefore, we rearrange this. X is equal to the inverse sin, 8 over 12. Put that into your calculator and we get 41.8 degrees to 1 decimal place.